Well, hello everybody and welcome back. This is definitely a good day to be at the bench. It's the weekend and we're having our first snow of the year, and it's really kind of one of those big wet snows that it's just cold and damp and just gross outside. So this is a good day to be inside in the nice warm house sitting at the bench. So what we have in front of us right now is our next project. And actually, it's not really our next project. I'll expand upon that in a minute. But what we have is a McIntosh model MR41 FM stereo tuner. Now, these tuners are some of my favorite, and not because they're the very best in the world or anything. I just kind of like the way they sound, and I like the way they perform. I kind of like the classic look of this generation of McIntosh equipment. This is the second one that I've had on my bench, and actually the reason I'm saying that this is not our next project is because this one's pretty much already done. I've finished it, and I kind of wish I would have done the video on this model because it had some very interesting problems when it came in. Which were pretty interesting to troubleshoot, and I wish I would have gotten some footage of that, but I just don't always have the time to video every single thing that I do. The good news is we have a second one of these because I got two of them that came in at once, so that'll be my third one that I'm going to be doing. The other one I did was a long time ago, but this one, it's a little newer version of the MR71. And if some of you are not familiar with these models, these definitely went through an evolution of change over their production history, and we can talk about some of that. This particular one is in older serial number, and this is one of the original designs and one of the older ones, and I really actually like it, although the newer ones have a little bit snappier tuning action on them when you bringing in stations, but they're very similar. They've just done some modifications over the years to improve the performance. Now there is a modification out there that we can do, and we'll talk about a little bit, that improves the stereo separation. And this was bone stock when I got it. It had some pretty bad issues. It had a terrible hum. The multiplex section of the receiver didn't work at all. Just had a bunch of it didn't have any of the stereo separation mod done on it. The audio section had bad capacitors, so the filter cap was terrible on it. Really bad, like almost couldn't even turn this on. The hum was so bad. But we got it working, and I'm going to just play something for you. I have it tuned into a station. I just want you to hear this first of all. I don't know if this microphone will pick it up because this is my speech mic and it's facing me instead of facing the bench. But we'll see if we can get it to pick it up. Let's listen. As you can hear, it's a 400 hertz tone, and it's very kind of staticky. And you might ask me, well, what's so great about that? It's a terrible, staticky sounding 400 hertz tone. But the thing that once I show you, I think you'll see why I'm so impressed with this. As you can see, that is 1.5 microvolts. That is a tiny, tiny little signal. And this thing is picking it right up. It tunes right into it. That's, in my opinion, for a tuner of this era and so forth, that's pretty amazing. And you don't have to go up very much for it to clean right up. At 4 microvolts, very little background hiss and background static interference. These tuners are really, really good. They're very sensitive, and one of the reasons is it's kind of a little bit of a unique design. It's pretty basic as far as a tuner design goes from this era, but one of the things I thought was kind of neat, and I've had a couple tuners like this, and this is one of the models. If you look down in here, this is actually, if you've never seen one, this is actually a vacuum tube, just like the rest of these. It's a triode type vacuum tube, and it is in a metal case, and this type of tube is called a nuvistor. I don't know if some of you may never have heard of nuvistors before, but they are tiny miniature transistors, vacuum tubes. And even though there's a vacuum tube in there, it is not much larger than a transistor. So here's just a basic little transistor, and you can see it's very similar in size. It's a little bit taller, but it's very similar in size to a transistor. So the way this thing works actually makes it a very sensitive tuner. Now another really neat thing about this tuner when it came in was it came with this. Still in the plastic wrap, it came with the little warranty card. It came with the original owner's manual. Pretty amazing, huh? And most importantly, look at this. The original McIntosh schematic. Unbelievable. And the thing that's so special about this, and I'm sorry I have the camera on the lower position right now on the mount, so it's a little bit not really set up to look at schematics. But the thing about this schematic that is so special is that this is the early version of the schematic. In other words, this is the one from 1963, and this is the one that has the original schematic circuit design from the early serial numbers. Later on, they made changes to the multiplex circuit. They changed it around, and they made changes to the audio output circuitry over here. And we'll get into whatever, the improvements or whatever. We can get into that later. But the thing is, I've done a lot of online searching for these schematics, and the newer style seems very available. You can find it pretty much at most of the normal haunts that you find schematics. This particular one, however, is not so available. It's very hard to find. So I scanned this. Strangely enough, this sheet is not a standard 11 by 17 paper. It's slightly larger. So when I scanned it, I actually had to scan it in two sections and kind of to get it all in there. So you could see when it prints out, here's an 11 by 17 sheet, and you can see it's just ever so slightly bigger all the way around. So I just scanned it in two parts to catch all the circuitry in there. And now I can print it out on 11 by 17 or by 8.5 by 11 if you want, whatever type of paper you want to use. But yeah, this was really a find here. So I was really happy to find this. Again, if you try to service one of these older versions of this tuner and you do not have the correct schematic, it will lead you down a rabbit hole, because there are differences in the actual circuit, especially when you get into the multiplex section of this and the audio output section. So anyway, this one's done. And before we start our project on our new one, let me go over a couple things, because I think it was very interesting what I found with this one and what was wrong and what we had to do to fix it. Alright, the first thing we need to know before we start working on any of these tuners is that this little schematic notes page is very important because, as I said at the beginning of the video, the MR71 went through several different variations of circuit design during its life. And whenever you work on these, the serial number of the unit is very important. And the other thing is the history of if it was serviced or not, because some of these have been modified or upgraded since they were purchased. So you really have to kind of do a little bit of homework before you even start to work on one of these tuners. And these notes are very important. If you get into the schematic and you look at something, and again, there is more than one schematic for these. There's the older one and there's the newer one. This applies to the newer schematic. And you'll see that there are quite a few differences between it and the older schematic. So we'll look at the older one because we're going to talk about the tuner that we just did. Then we're going to actually bring another one on the bench that's a newer model, and we're going to actually restore it. So the very first problem that these have is they're very old, and because of that, these capacitors will tend to dry out and fail. Now, there's two failure modes for these old electrolytics, and depending on how it fails, it will change the problem that you'll see, the symptoms. With this particular capacitor, it didn't develop a short. In other words, it developed a high ESR, which made the capacitance actually look higher. So, for instance, this one said each section of this can is supposed to be 50 microfarads, but it actually would read much higher, would read upwards of almost double that. However, it would not present a short circuit to the signal, so to the power supply. So it wasn't, as you can see, the resistors were not burned up like you would see with a shorting capacitor. Okay, so the other failure mode is that these capacitors can actually short circuit and almost act like, instead of capacitors, they act like resistors. So depending how it fails, you can either have a short circuit or you can have an open circuit where there's no capacitance or very little capacitance. This one did the very little capacitance thing. Even though on a meter it would read very high, as soon as you applied any kind of energy to it, it would just almost act like it was not even there. So what that did was all these sections in here created a terrible hum in the receiver. The tuner worked just fine, but when you got out to this audio section, if you look at the very output right here, you have a decoupling capacitor that's 1 microfarad. And by the way, these were really bad. They were, again, they weren't shorting, they were acting almost like an open circuit. So when you put a capacitance meter on there, well, I have one. I think I can show you possibly. Hold on. So what we have is a 1 microfarad capacitor. I don't know if you can see that in there, but it's 1 microfarad. But if I check the value, it reads almost double, 1.98 microfarads. And that's what these do. They're not shorted. But if you do a leakage test where you're applying, like I'm applying 100 volts to this 150 volt capacitor, you can see it's got a lot of leakage in it too. And some of them, the other one of these actually had double capacitance, but it showed very, very low leakage, like there was almost no leakage at all. So again, it depends how they fail. Now getting back to the schematic, if you look, you have 74 volts. And that 74 volts is coming from the end of our power supply dropping network. And you see all these, resistor, dropper, and then a capacitor, dropper, capacitor. These are all pi networks. And we get to this last one here. That should be a very, very clean DC signal because of all of the pi networks it goes through. But when you get down to here, if there is any hum whatsoever or any variation on this AC voltage, on this DC voltage here, because this is a high impedance circuit, it will impose that noise right here. And so any tiny little bit of hum here will get directly out to your output, and it will give you very loud, nasty sounding, just very loud, nasty sounding hum. So we had to replace all these capacitors. So what we did was, and I have one for the other tuner, you can get these online. I got mine through Antique Electronics, and it's identical except for the voltage. These ones are rated at 200 volts. This one's rated at 350. And no, I'm not really worried about it not being formed because the voltage is a little bit lower. It'll be just fine in this circuit. So this capacitor is just fine. So we're going to replace that. The one that we're going to put on the bench works a lot better because it's a little bit newer model. But still, we're going to replace the filter cap, because we know when you have a 30, 40-year-old, 50-year-old capacitor, you know it's going to eventually go. The more interesting thing was we were not able to get the multiplex circuit to work at all. It just didn't work. In other words, you had good mono sounding stereo, or good mono sounding FM, but we could not get stereo FM. And after much troubleshooting, as it turns out, this transistor was faulty. Now here's another part of the circuit that is unique. On this older model, this is a MA113 transistor. And if you look right here, there it is. I don't know if it's focusing on it or not. But the thing about it is a PNP transistor, and it is a germanium transistor. And luckily, I went through my old stock, and I had one of these still sitting, in my old germanium transistor stock. It was a complete, perfect, perfect replacement for this. And lo and behold, it was brand new in the package. I opened it up, I tested it. It was perfect. I put it in. It fixed it. This circuit here is kind of strange. This is an LDR, which some of you guitar folks out there may know that this is kind of the heart of some tremolo circuits that are used in guitar amplifiers, where you have a little neon light and a light-dependent resistor, and it's in an enclosed little package. And this is what they're using to set the sensitivity to turn the multiplex circuit on and off. So when the voltage gets up to a certain level, this will light up to a certain level. It will change the resistance to a certain level, and that will toggle on our multiplex, and then you'll get the light will light up. So very unique little circuit. And the thing is, they changed this on the later models. Let's take a look. So instead of this circuit, it gets updated to something that looks like this. And if you look, it is a lot different. If you look at the threshold adjustment for our multiplex, and you look at the way they do it here, if you look at the transistor, they're now using an NPN and instead of a PNP. And I believe this might even be a silicon transistor instead of germanium. It is a much different circuit all around. So you can see where they put the Zener diode here, and the 6.3 volts that comes in is going directly into the bulb. And you can see down here it's going in directly to this bulb here. Well, it's similar, but you can see the changes that they've done. So if you try to work on the one model and you have the schematic for the other model, you could very easily get confused because the wiring doesn't match. The other thing that changed, the other significant change they made in this, was the audio section. So here's the original, and this is the one that you just listened to or just saw. We didn't do any tuning with it, but trust me, it works very well. There's just a single decoupling capacitor, and then they split the signal off into two potentiometers. One of them is for your there's a volume control, variable output volume control on the front panel, if you noticed on the tuner. And then this pot is mounted to the rear of the chassis next to the output jack, and that's what's called your fixed output. You can adjust your fixed output. So you basically have two separate outputs that you know, one of them you can access from the front of the chassis and one you can access from the rear, and you have two separate outputs. Now, there is a modification that, trust me, very greatly increases the stereo separation. And it's this right here. They just have you take a 27K resistor and a 0.0015 microfarad or a 1.5 nanofarad capacitor. You put them in parallel, and then you just shunt them between pin 8 of each of these 6BL8 audio tubes. And boy, what a difference it makes. You can just flatten out the suppressed channel when you're doing your right and left. It just flattens it right out. You get very good separation. Big difference. Without this resistor, you really can't get total stereo separation in this receiver in its original form. It's pretty good, but it is big time different just by adding this little component in here. Now, if you notice on the later model, that's in there. They have it in there. And they also made some changes to the output. If you notice, there is a 1 microfarad, which is what we originally had, but then they put it in series with a 10 microfarad, and they have a little bit of feedback here, and then they go out through this 10 microfarad to our output section. So this again is another mod that they made to make the audio sound a little bit better. So we'll do a little bit of poking around over there too. Obviously, these are directly in your audio path, so it's highly recommended you replace these capacitors, because obviously those old paper dry electrolytics are not going to be performing very well after 40 or 50 years. The other thing that I found on this one was there was this big dry electrolytic. That's the first one in the series, and that's this one here. It's a 40 microfarad. You can see 40. And this is the very first one out of the rectifiers. And these rectifiers here are selenium. And even on the newer ones, they're selenium. And it's recommended that you swap these out for some silicon ones and then put a little dropping resistor here. Simply because selenium rectifiers can and often do fail. Although the ones that were in this one were in very good condition. But just to make it a little more future-proof, it doesn't really affect the sound of the amplifier or of the receiver or the performance. So we put modern silicon. We'll never have to deal with those again. We'll never have any problems. So that's it. Those are the main things, and then just kind of going through it and doing some tweaking to get everything peaked out. Although it was very, very close, it wasn't very exciting alignment on this one because it was so close to being in, other than the multiplex being grossly out after I tampered with it. I didn't adjust it, but once I replaced those components and it came back to life, things were shifted a little bit and I had to adjust it, but it was not that hard. Up here is that new Vistor we were talking about, that 6DS4. As you can see, it's just a normal triode tube. And then that triode tube feeds half of this 12AT7 in a Cascode configuration. And that gives this front end really nice gain. So this is a really nice RF front end circuit for this tuner. And then it goes, the other half of that 12AT7 is your mixer from your local oscillator. And from there on, it's a pretty straightforward FM tuner. So very well designed. very well built, and that's why these are among my favorite tuners to work on and to have. So let's get the other one on the bench and let's see how it works. All right, well, here's our next one, and there you can right away just on the outside see some differences. The first thing is they added a little slider switch up here. I don't know if you could see it right here, and it allows you to have either bright or dim panel lamps. So the panel lamp, you can actually dim it down. That'll make the bulbs last a little bit longer, and it'll also make it not be so bright. So they added that, and right away you can tell the newer models because they added these nice painted stenciled covers for the SCA filter, for the tuning capacitor, your tuning gang, and for the power transformer. And they, like in typical McIntosh form, they put the little schematic of the transformer right on top of the cover. So the original early models did not have those couple features. If you turn it around, let's see here. And if we look, I didn't show you the rear of the other tuner, but right here you can see your 75 ohm antenna input, and it's for your standard coax connector. And then for your 300 ohm, you have your terminal strip. Well, on the older model, it had two of these terminal strips, one on top of the other. And this top one up here was still the 300 ohm. This was not present. There was another screw terminal down below, and it had your 75 ohm. So if you wanted to use a 75 ohm coax, you'd have to strip the ends and attach them to the screws. So this was a nice upgrade they did on the later models. One thing that these all share in common is that they used these kind of nickel-plated output terminals for the RCA, for output to your amplifier or your preamp. And if you notice, every one of them that comes in here like this is really badly tarnished. And unfortunately, that tarnish, if you clean it, will not bring these back to their shiny original state. All it'll do is it'll just rub off what's left of that plating. The plating actually tarnishes and deteriorates off of these. So really the only way to fix them is to replace them. These are crimped in. They don't have screws on them. They actually are kind of crimped, and they have these little star washers on the inside. We'll see those in a minute. And basically all we're going to do is replace them with these gold terminals here. So that's it. All right, for my favorite part now, let's flip this over and take a look under the hood. Okay, looking at the underside of this before we take it off, you may want to take note that these holes in here are not all just air vents. Some of them have little markings on them. So if we look here, for instance, you can see where it says L3, L1, C2, L2, T1, and so forth all the way around. What those are is those are actually alignment holes that you can put your alignment tools in and make when you're adjusting the tuner, when you're aligning it. And this is very important because with a lot of these tuners, there's a lot of exposed circuitry inside here, and it will change if you align this with the cover off and then you place the cover back on. There is a chance that it will change your alignment and throw it a little bit out of alignment because of the influence of the chassis and the shielding, with respect to outside noise. So the reason they do this is so that you can align it in the form that you're going to be using it, which is with these covers on. And there's a whole bunch of screws here, and these that I have removed most of, and they actually will ground this bottom plate to the chassis. So very important when you do the alignment, you want to kind of do it that way. At least your final alignment. Sometimes we may get it in range a little bit, with the covers off because we're troubleshooting things. But then you always want to go through, put the covers all on, and do your final run through of it to trim it up with all the covers on. So let's get this cover off and see what's inside. So taking this cover off, the first thing you're going to notice is that this bottom cover is made of solid copper. How often are you going to see that today? And it's very heavy. It's a very heavy, very thick, solid copper. If you kind of scratch it a little bit, you'll see this is all copper. And so it won't tarnish or anything. Very good. And now we're in. And you can see inside here, here's your audio output tubes. And you can see that little modification that's done by the factory on this one. And here's your 0.0015 capacitor. And here's your 27K resistor. And there it is going between the pin 8s of the tube. The older models of this, you will not see this. Also, on the older model, you will have that 1 microfarad capacitor, the big ones, like I showed you earlier. This one will actually be located right here, and it will go right from this pin directly to this potentiometer and then split off through this little shield out to the front potentiometer. So you only have the one cap and the other one cap here. And right here you can see, here's your 1 microfarad, the new version, and they're Spragues. And I would venture to guess that these are probably going to be perfect. We're going to measure them, but they're probably not going to need touched. And right here is your little 10 microfarad 3-volt audio capacitors, and they are audio grade Sprague electrolytics. So if they're good, we're going to leave them in. If they're not good, obviously we'll have to replace them. We'll just see. But needless to say, that's the difference on this one. Again, if you look right here, this is a commercially built LDR. This is that light, that little bug, that the roach, whatever they want to call it. So you can see the light is on this side, your neon light, and here's your photoresistor on this side. If you look in the, I kind of wish I would have got some pictures. If you look in the old version of this, it looks like a homemade thing that you would see like in some of the old Fender amplifiers and so forth, with, you know, plastic heat shrink over it. It really looks homemade. And obviously you can see this, with this one, they replaced it here. There are some mods that some people have done out there where they've actually were able to use an opto-isolator IC. I don't know if I have one here. I'll show you if I can find one. Sorry, I don't have one handy. They're all at the shop at work. We use them a lot in my line of work. But anyway, they just use it looks like an integrated circuit with four or 6 pins on it. And you can add some resistors, a little resistor network, and you can fabricate one out of that with a modern component if this ever goes bad. Here's your diode. Again, this is a modern silicon diode. The older version of this receiver will have a glass, what looks like a glass diode in here. Nothing wrong with it. You can leave it in. It doesn't go bad. I mean, if it's good, don't worry about it. If you look down here, the configuration is slightly different in the older models, how they lay it out. But essentially, they use the same components. These are your selenium rectifiers. Here is your 40 microfarad capacitor. And you can see it's a little different version than the one that came with the older model. And then that goes to your power supply here. And you can see once again, the older model used a larger resistor, and they are slightly different values. Okay, this one used a 2.7K dropper, and on this one it's a 2.2K, and it is in the schematic. You can see the difference. So just some different, some things that are a little different. They laid out these big dropping resistors differently on the newer model. You can see they drilled holes and there's no wires around it. In the old one, they ran the wires right alongside this, so they didn't have good heat dissipation. So these are all little changes that probably you could make that you could make if you wanted to kind of make it more like this version. So this is all it is little tiny improvements. I didn't notice any problems with the old style power supply. It looked perfect. As you could see, those resistors were perfect. So really there's no need to change it, but this is the newer version. Over here is your multiplex board, and this capacitor, and I think another one, there's a couple capacitors on this multiplex board, and that transistor, turn this around, you can see is right here, and it looks as if somebody has replaced this one. I don't know. No, it's original. Nope, that's original solder, so that's original. So you can see this one's got that little heatsink tab integrated onto it, and it's like a little TO92 style package, and that's the NPN versus the PNP. These boards are different. So this board has a different artwork number than the one on the older. So again, some of the components are going to be laid out a little bit differently. Several of these ceramic capacitors, not all of them, but some of them on this board, actually are directly in the audio path, and probably it would be an improvement to replace these noisy ceramic capacitors with some good film capacitors. So we may look into doing that on this one. Couldn't hurt it. Certainly won't hurt it. Again, it's FM stereo. It's not as clean, high fidelity as you're going to hear on a on a vinyl recording or or an MP3 or a lossless recording or CD or something like that. It's a tuner, and it's coming through the airwaves, so it can only be so good. But still, you want the audio path to be as clean as possible. So it might be a good improvement. So there you go. As you can see, this is not a highly complicated tuner, and it's laid out very well. It's very serviceable. So if you want to, once you understand how these work electronically, this is a good tuner for some of the newer technicians to kind of work on. You just have to be careful, like anything, but certainly much easier to work on than some of the newer solid state things that you've seen on the bench. Certainly a lot easier than some of the Pioneer and Sansui stuff we've had over the last few videos. So again, a good solid basic design that works really well and sounds really good, at least to my ears. So let's do some improvements on this and go through it, and we'll then see how good it works. Okay, sorry, I really like Rush, I'll admit it, and I heard it tuned in, so I had to give you a little clip of that. Anyway, so you can see this works right out of the box. It's working pretty well. There's no hum. The sensitivity seems pretty good. So really, we're just kind of doing some future proofing on this one. The last one, as we described earlier, had all those issues we had to fix. What we want to do is make this one so that won't happen to this one, so that whoever ends up with this tuner is going to have it for a very long time and won't have to worry about anything failing. So a question I get quite often on this, I'm going to shut it off, is how do you bring these up on a variac? What's the proper way? So first of all, bringing things up on a variac really is dependent upon the device that you're going to test. Some things don't like variacs. So for instance, some of the Carver gear that we've worked on with the magnetic field power supply, not a good idea to use a variac on those and creep up on the voltage. A lot of large amplifiers that have soft start circuitry, which is designed to slowly charge the capacitors at a certain rate and then bring in full power. Some of those will work with a variac and just kind of kick in when they need to. Some of them you can actually cause damage to the power supply and to the soft start circuit if you bring it up on a variac. So again, it's dependent upon the equipment you're testing. On something very basic like this, where you just have a transformer, a basic power supply, nothing special, like this, your radios that you're working on, any of the older tube radios and things, anything like that, smaller receivers and things, it's fine to do what we're going to do here. So this one is a good candidate for a variac. If we wanted to test to make sure one of these caps isn't shorted, for instance, and going to damage those selenium rectifiers. Selenium rectifiers really don't like heavy current. They will blow up. I mean, they will fail instantly if these caps are bad. So we want to avoid that. How do we do it? Well, if you have one of these all-in-one things, this can do everything for you all in one. This actually has two transformers in it. It has an isolation transformer, and we've talked about that in earlier videos. Quite a few times I've mentioned an isolation transformer. But it also has a variable auto transformer, which is called a variac. And what that does is it's a transformer that only has one winding, and it works like a potentiometer in that you can rotate. There's a mechanical tap on that transformer, and that transformer is round, and as you rotate this, you can select or adjust the voltage coming out of the outlet. So this is a isolation transformer and a variac all in one. The other nice thing is it has the metering circuits built right in, so I can actually switch between, I can measure how much voltage is coming out here from my variac as I turn it, but I can also monitor the current coming out. This is the most important thing. Whenever you're using your variac, you really want to monitor the current being drawn as you turn that variac up. Number one, you're going to protect the circuit that you're working on, because once it gets up to a certain level, if you see there's heavy current, you know there's a short, and you don't want that short to damage any more components than already are. And number two, you're going to protect your variac, because if there's a shorted component in the device you're testing and you put that short across your variac, you're going to damage that little wiper, that little tap on your variac knob, and damage your variac. So you really want some sort of a amp meter, AC amp meter, in series with this outlet. And that's what this meter is. When we go into amps like this, when we switch in amps, this will read from 0 to 2 amps. So full scale will be 2 amperes and 0 here. So it's very sensitive. Once you see some heavy current drawing, you can watch capacitors charge as you turn this on. We're going to do that. So I have the device turned on. I have it plugged into the variac. I have the voltage turned all the way to 0. And if I switch this on, you can see I am not drawing any current. So I'm set in current mode right now. Let's bring this in a little closer. Let's see. Let's see if I can. It's kind of hard to get the glare off of there. Sorry. I think you can see the meter. There we go. Is that better? Better. Okay. So let's start turning our variac up. And what we're going to do is we're going to look at this meter, and what you're going to see is it's going to deflect a little bit as the capacitors charge. So capacitors, when they're first charging, draw very high current, and then as they charge up, the current drops down. Remember Eli the Iceman, any of you electronics students. So let's turn this up a little bit, and you'll watch this deflect a little bit. If it goes up and doesn't come down, that means that that capacitor or some component in there is shorted. So if I rotate this, and you can see it goes up, then it drops way down. And now there's going to be some rest current in here, and that rest current is because you have all the circuitry, the filaments in the tubes, on all the electronic components. As they come up, you're going to have a tiny little bit of current. That's normal. But that big surge current should go up and then go right back down. As I turn this up some more, it'll do it again. And once those caps get kind of up to their level, roughly, then that current won't go spiking up, and it should stay low. If there's a short as I'm rotating this, so I'm about halfway up, and we can check our volts, and you can use your voltmeter to measure the volts on your outlet. You can see I'm at about 85 volts right now, so we're up pretty high. Go back to my current, and I have the variac marked when I'm at 120 volts. I put a little tick mark there, a little label, and I can rotate this up until you can see it's going to sit just under half of an amp, or just under 500 milliamps. So we're somewhere around 400 milliamps for the whole receiver right now. And we're at full power, again, about 450 milliamps. And that's about all you should see on this tuner, because again, this doesn't have a high current amplifier to drive speakers. It's just a tuner. So I would expect the filaments of all the tubes and everything to draw that kind of current. So that's how you bring this up. Again, we want to monitor this for a while, because let's say a capacitor begins to fail now that you've energized it. This unit has been turned off for many, many years. You know, you find this thing at a flea market or an estate sale, and you want to bring it up. It may function properly at first, and this is proper. However, you might sit there for about 5 minutes, and all of a sudden you'll notice this needle start to creep up. Your current will start to creep up, and that's because one of those capacitors is beginning to break down and fail, and it's beginning to turn into a short. When that happens, you want to shut the power off, because what it's going to do is that excessive current is not only flowing through your variac, but it's also flowing through those rectifier diodes, or those selenium rectifiers, or your vacuum tube rectifier, whatever the case, and you are going to damage those components. So that's really how you bring something up on a variac. Again, you don't need a fancy device like this. There are many different versions of this from many different manufacturers. They're all the same thing. It's an isolation transformer, a variac, and some metering. But you can make your own using a standalone variac, a standalone isolation transformer, and your own amp meter, or even one of those kilowatt units like this down here. And you can buy these very inexpensively at at most department stores or hardware stores. The thing that's bad about these is they won't come on until that voltage gets up to a certain level, 40 or 50 volts. So if something's really hard shorted, by the time this thing turns on, it's too late. You've already put a lot of current through that device. So I don't recommend these for this. You're better off just taking your, using an amp meter or an amp clamp or something and monitoring the current that way. So anyway, there it is. It's turned on. And if we turn the volume up, we should be able to hear something now. Yep, it's working. And as you can see, this tuner works very, very well. I mean, it's right out of the box. It tunes. It does have some, well, when you tune it, I've noticed it's kind of has some warbliness to it. I don't know how to describe it, but it seems like the I don't know, auto frequency control on it, the AFC or whatever, is kind of struggling a little bit, and that could be due to capacitors or alignment or something. But other than that, it seems to be working very well. So let's tune around a little bit and see how it sounds. Wow, this is Led Zeppelin day, I guess.
Treated us like we were. September 3rd.
Okay, so you get the point. When these tuners are working properly, it should snap onto the station when it finds it. Did you notice like you had that static? I have the muting turned off on purpose. And what you can hear is you can hear the static, and then all of a sudden when you get over a station, it snaps right in and kind of locks onto it. That's a properly aligned receiver should work like that. Even these analog ones, all analog, there's no synthesized tuning, there's nothing like that. This is all coils and capacitors. So once again, if it's set up properly, that's how it should work. So this one's actually, my guess, we're not going to have to touch the alignment at all. We'll go through the motions and test it, but I think this one is still in very good condition. And I'm going to replace some of the filter capacitors simply because they're so old, and I would hate to think that we send this thing out to a new owner or to the present owner, and down the road this thing will dry out and go bad. Probably if we test it, they already are depleted somewhat, but because these amps are so over-engineered and well built, you have some latitude that you won't notice anything. So once again, that's where we are. These are great receivers. Let's flip it over and change a few components out and test it again. Okay, so a lot of you ask quite often, how do you clean controls on these things, One of the things that you need to know is you don't want to just get a can of deoxit and just hose it down like a fire hose. Deoxit is not like lower cost contact cleaner. So if you look at this stuff, this like QD contact cleaner, a lot of the cheaper contact cleaners will evaporate, which is a good thing. Whereas deoxit actually has a deoxidant in it. It's like a coating, and that coating will stay, it will remain, which is good. The problem is when you start to get it on circuit boards and delicate circuitry from spraying it around, it splashes all over the place. That actually can be detrimental. So how do you do this? Well, what I do is, again, I use the low-cost cleaner, which is usually just something that evaporates, like mineral spirit type thing, and it will mostly evaporate. And you can buy this very inexpensively in hardware stores. You have to be careful that it's stuff that is plastic safe. You can see so that it doesn't damage, because some of this stuff is very caustic and it will damage plastics and things, so you got to get the right kind. But it's low cost and it evaporates. And if I really need to just spray out a pot to clean it, I'll do that, and then I'll be very careful with my deoxit. Now, to clean something like this, so we have a connector down here, or a switch, and you can see how black and tarnished that is. That's pretty much how all these end up. So what I do is I actually do use deoxit, but what I do with the deoxit is I squirt some of it from the deoxit can into a little container, and then I use something like these little dental cleaners. They have floss on the end of them, just like a little cotton on the end. You can buy them in the drugstore, and I will actually dip it in, soak it up, and then I'll go in here, and let's see if we can get it on camera, and you just kind of gently clean it off, and you see how it turns shiny immediately? It just takes that black right off. And that's really what we're trying to do, is go all around it and very gently clean this stuff off. And the deoxit does a good job of cleaning this way, and it will also leave a coating that will prevent this from tarnishing in the future. Okay? And it's just very simple. You just take your time. Don't be in a rush. And be careful around these little spring terminals. These little spring terminals actually clamp down on this little slider portion, and they actually make contact with this part. If you bend these apart, they're very, very delicate. They will no longer make good contact. So never pry out or try to wedge anything down inside there. You just get this swab saturated with the deoxit, and just by rubbing a little bit over the top, it'll run down in there. Okay, and then we can get in behind a little bit, and then you just, once you clean it, you work the control, and you can see how nice and clean it is. And that's really the process. With these potentiometers, if I have a clear area around it, I'll take a little paper towel, place it underneath, and then very gingerly spray some deoxit down in there. Just a little bit is all it takes, and then work the control back and forth. And that's really all you want to do. Never stick the hose of the deoxit directly in here, because there is actually a wiper that goes around in there, and you can damage that carbon track or that wiper in there. So you just kind of get it right in the edge there, and just shoot a few little drops in each side. It's all it takes. It spreads out very quickly. If it's a particularly dirty potentiometer and I need to spray it in there a little harder to wash it out, I again will revert to this stuff, because it will completely evaporate and not leave any residue. And then follow up with a little bit of deoxit to finish cleaning it up, or to get that little deox coating on there. So that's how I clean them. And again, everybody has their own little method of doing it. Different people will say, no, I don't do it that way, but that's how I do it. I've never ever had a problem over the years doing it that way. Just taking deoxit and hosing down a pot, you probably will have problems down the road if you're not careful. Especially when you're around circuit boards. These older fiber circuit boards like this really do not like any kind of liquid like that deoxit. It'll soak right into this board, and it can cause a lot of problems. It can cause the tracks to come loose, because the way these tracks are formed on here, it's not the same as a modern circuit board, so you could have problems. Just a little word of warning. So that's how I do it. We're going to finish cleaning this up off camera, because I just did this one, and you can see it was completely black. And you can see just a couple minutes with that cleans it right off. So I hope that helps you out a little bit. The other thing is, you can get pure deoxit that does not have the cleaning agent. It's called D100. 100 means that it's 100% of the deoxidizing solution and 0% of the evaporative cleaner. If you get the deoxit D5, that means it only has 5% of this and 95% of something like this in it. And that's nice, because it will evaporate a little bit and then leave the other stuff as a residue. But still, once again, even this, if it gets on a circuit board, that 5% can cause a lot of damage to your board. So just be very careful. That's why I would prefer to just spray this in a container and gently clean it this way. So I hope that's a little bit helpful to you. So let's move on to the next thing. Okay, we're starting to lay out the capacitors that we want to replace, and we have the new CAN capacitor that's going to go down here. I have the new one for over here, and I have the new one for here. And unfortunately, as I predicted that these were going to be good, these two down here and these two here, unfortunately they're actually really not good. Both of these are reading very high, and they're reading leakage. This one is basically a short, and this one is way out of tolerance and leaky. So they are going to have to be replaced. And we have some nice new Solon capacitors. And for the 10 microfarad, we have some Nichicon Muse series fine golds. So those should work out just fine. We have these two little Black Beauty and Bumblebee capacitors. We're going to replace those. They typically go bad. Those are paper foil capacitors. And since this is a vacuum tube circuit and there's high impedances involved, we did go through and mark for the 0.1, we marked the outside foil. Again, this is kind of a controversial thing to me. In this instance, with this size of capacitor, I think it will make a little bit of difference if you mark the outside foil. But when you start looking at the real tiny capacitors like this, and this I'm not using in here, it's just an example, they're so physically small that by the time the outside foil would even be a factor in this, I would say that your leads themselves would be just as susceptible as the foil itself. So it's kind of one of those things where I'm not always convinced about the outside foil thing, and I think that's one of the reasons you don't see them marked, especially when you're using capacitors in newer equipment like transistorized or solid state. The physical size of them is so tiny, and a lot of the circuitry is low impedance, unlike vacuum tubes that can be very high impedance. It's not always such a big deal anymore that it used to be. But you know what? I'm very interested in that whole thing, and we're going to do an experiment later on. We're going to do a video where we're going to restore an old vacuum tube AM radio, and we're going to first replace all the capacitors with the outside foils the correct way, and then we're going to reverse them and put them in the opposite way and see if it makes any difference, because I'm really curious about it. I do know on the old wax capacitors it is a huge deal because they're physically much larger and there's so much more surface area, and the foil and wax paper that they use in those is very thick, so it actually does make a lot of sense. The outside foil is a huge deal. So anyway, more about that later, but I'm still going to do that for these ones because this is vacuum tube. So we're going to get those all replaced, and once we get everything swapped out, we'll come back and see how it works. Okay, the deed is done. Let's go over what we did and take a look at it. So the first thing we did was we modified the power supply. And if you remember down in here, zoom you in, you had the two little, what are they called, the selenium rectifiers, and those have been replaced with regular silicon diodes, so you can see. I just put in this terminal strip. And then of course whenever you go to these diodes, there is a voltage drop on selenium rectifiers. So before I went and did anything, I measured the voltage across one of the resistors and used Ohm's law to calculate the current flowing through that resistor, and then determined, and measured the voltages and everything, and I compared it after I put this in. And long story short, after doing some testing, the voltage drop at this point right here was only about a couple of volts. So long story short, it came out to be roughly 100 ohm resistor got us within 1 or 2 volts of where we needed to be. And so that's what we put, was a 100 ohm dropping resistor, and this is actually a aluminum bodied one. They're pretty heavy duty. It won't even get warm. It barely even gets warm. And I really didn't want to modify the chassis. I did not want to drill any holes or do anything like that. So I used very, very stiff solid copper wire to solder it into this side and then down in the bottom of the terminal here, so that holds it tight. But then in addition to that, I used it's called heatsink glue. So it's an adhesive that also acts as heatsink grease, but it hardens as it dries, and it actually, you can use it to glue small heat sinks and things onto components. I use it for this kind of thing because it's just right. The copper wire is actually going to hold it in place, but that'll actually provide a little bit of heat sink for it and secure it even more to the chassis. So we did that. We replaced the main filter capacitor, and here's the old one. You can see we removed, and put new resistors while we were at it. And these are metal film resistors, so they're not going to wear out, or they're not going to overheat or anything like that. I just replaced this little ceramic bypass disc just because it was easier than trying to desolder the old one. The old one wasn't bad, but I just didn't want to feel like going through that. Moving along, I replaced this capacitor here, and that originally was this big one in there. Nice new 105-degree cap in there. And then getting down into the audio section, you can see where we replaced our 1 microfarad with some nice Solon capacitors. These ones I did mark the foil end and put them in the same way, although I don't think it's, again, that important in this position, but I did it for precaution. And then these tiny little Muse capacitors I put in down here, the 10 microfarad, and then they go to this pot. And then, of course, we replaced and put in some gold new jacks that won't be all tarnished and dirty. We replaced these couple of paper capacitors that were in here, just for future proofing it. And then we just went through and tested everything. And and I did the 2 audio path capacitors on this board too, these little 0.02s, and those are replaced with 0.022 film capacitors here, Mylar. So everything's good, and we're ready to go now. Our voltages are all good here, and so really we're down to just testing it out and see how it works. Okay, we're all connected up, and I just have a signal going into the antenna jack right now. This tuner really doesn't need much in the line of alignment, I don't think. We're gonna find out, but I have a feeling it's going to be pretty close. We'll see though. So I have the Sencor SG165 up there. You can see it. I am just using it strictly as a multiplex signal generator. That's it. It's just producing the multiplex signal. And I'm putting that signal into my HP8657, which is right here. And you can see here's your external modulation input. So I connect into there. I have external modulation selected for FM. And 100 megahertz, just to middle of the band. And 1 millivolt, which is 1,000 microvolts, which is bottom line, which is what they're asking for. That's what the instructions, they want you to drive approximately. They just want a really, really strong signal in there going in. So there we are. And I'm not totally matched with a matching network. That's okay. For this particular test, we don't need to worry about that a whole lot. We could do it, but I'm not going to worry about it. And so I'm coming out of the right and left outputs, audio outputs, which would be normally what you would connect to your stereo. And you can see up here the signal. And now what I'm going to do is I'm just going to shut off one of the channels. In other words, we're only going to modulate. So technically one of these should just go flatline and the other one should stay unchanged. So let's turn off the right, and you can see it does get smaller, but you can see that there's bleed over. We call that bleed over, and that bleed over, that means our stereo separation is not very good. Okay, in a perfect world, this would be a completely flat line, and this up here would be full signal. So really, all we're going to do now, and that's just a little alignment that's gone out. And to adjust it on this particular unit, you're just going to adjust the 19 kilohertz phasing coil, which is just a little adjustment right here. And I'm just going to go in there with the tweaker, and I'm going to adjust that and see if we can get that a little bit better. Again, this is the later model tuner, so it should have a much better stereo separation than this. So So let's go and adjust it and see. Yeah, there we go. And then look at that. Almost perfectly flat. Nice. And you see how this one came back up. Now we want to switch from the right channel to the left channel, and of course it's going to scroll around because my sync is set on this one, so it's going to jump around, but at least we can see. So go back on, and you can see that one's nice and flat up there as well. So there you have it. So we know that the stereo on this at least is working very well. Again, we're probably not going to go ahead and do a full alignment. I don't like adjusting these unless they really need it. We're going to kind of jump ahead a little bit now, and we're just going to kind of check our sensitivity and see what we can get. Let's see here. So I'm going to switch out of stereo mode, and I'm now going to go to a mono FM signal, modulated, and we're just going to see how low of a signal we can get and still be able to see or hear that the carrier, or the audio, I'm sorry, on the carrier. So let's check it out. Okay, for starters, we just have internal modulation, 400 hertz, and FM. I'm tuning to 98.3 megahertz because that's kind of a quiet spot on the dial where I am right now, and it's kind of, again, in the center of the range. And I still just kind of left this really strong signal. This is extremely strong, but we just want to get it tuned first. What we're going to do is we're going to tune this using the audio up here, okay? And the reason we're going to do that is we want to make sure we're really centered on the signal. So if we go up to our scope, I'm going to start rotating this, the tuning knob, and when I hit the station, you're going to see it. You can see right there we're starting to come in, and there you go. And then you can kind of see if I go over it, it kind of starts chipping the top part off. If I go the other direction, it chops the bottom. But when we get it centered, you should have a nice, clean sine wave. Now we know we're kind of tuned right in. And if it's not right, if something's not right with the discriminator or something, down here, when we look at our meter, it won't be centered. That's our tuning centering meter. And if you notice, it's right on center. So first of all, we know our discriminator must be pretty well lined up. Now that we're on signal, we're going to start just ramping down our amplitude of our RF, and we're just going to see how far down, as far as millivolts are concerned, how far down we can get. And again, we could also use dBm, it doesn't matter, but these old stereos, they all speak in millivolts, and they're talking about EMF, actual voltage applied across the input terminals of the antenna jack. So let's start going down. Right there is 316 microvolts, 100 microvolts. So there is 1/10 of what we originally were driving in. We still have a nice strong signal. There's 31 microvolts. There's 10 microvolts. So now we're down to literally 1/100th of what we originally were. And look, nothing has changed. We still have a nice solid sounding signal. We're now down at 3 microvolts. Okay, and I'm sorry, did I tell you millivolts earlier? We were in microvolts. Sorry, guys. So, and you can see now the tuning becomes more critical, and you could tell we were a little bit off center. See how I just barely moved the tuning knob, and you can see we can still get it nice. So we're now at 3 microvolts. Now the specs of this tuner, I believe, should give us, and again, we could put our distortion meter on there if we wanted to, but I'm not going to get all fancy like that. Let's see. I can't find it. Oh, here we go. Let's see what it says. And it says the usable sensitivity, if we look up here, usable sensitivity should be about 2.5 microvolts for less than 3% noise and harmonic distortion. So again, we're just visually looking at the distortion. We could put the distortion meter on there and verify that, but I'm at 3.16 microvolts. We're now going to go to 2.5 microvolts. And now you can just start to see a little bit of noise at the top and bottom, and it's clipping on both ends equally. That's good. So again, it's a very listenable signal with 2.5 microvolts. And I can even go down to 2 microvolts, and you can see the noise starts getting noisier, but if you notice, there's still a listenable signal. So if you're not listening to high fidelity, you just want to hear the voice. For FM, this is pretty good. Let's go down to 1.5 microvolts. And you can see it's still there. Now there's a lot of static and a lot of noise in it, but you can once again still hear the audio. Remember, this is the audio going in that would be going into your amplifier. Let's try 1 microvolt. I think we're going to lose it there. Nope, still have it. And you can look over here. 1 microvolt. So I think the sensitivity on this tuner is pretty good. The other thing we're looking at is the dial accuracy. So let's turn this back up to a more respectable level of 10 microvolts. And now we're going to check our dial accuracy. I'm just kind of showing you how to do this without using all kinds of fancy test equipment. We're just going to use a signal generator. As long as you have a signal generator with FM modulation, we can do this test. So let's start out at, let's say, 90 megahertz. So frequency 90 megahertz. And I'm going to tune down here to 90. And you can see the signal coming in. And looking at the actual meter, we want to look at the meter for centering, and we want to look at the signal strength here, and you have your multipath, and you can see just centering it right on there, I'm almost dead on 90 megahertz there, very close. See if we can see it, and you can kind of see it's pretty close, not perfect, but very, very close. And we're centered right up on the signal. Okay, so now let's go up to a center, like let's try 100 megahertz. And once again, we're going to do the same thing. And you can see dead centered, and we're right on 100 megahertz there, and beautiful signal. Now we're going to try 108 megahertz. Again, we're going to go up here, tune it in, right on signal. And you could see just a little hair under, so we're a little hair over on this end and a little hair under on that end, and that's perfectly okay for me. You could go in and set it dead on if you wanted to play with the IF a little bit, or the RF adjusters, but it's not far enough out for me to even want to deal with that. And you can see nice audio. The other thing you want to make sure is that the audio level that you're getting out with the same signal in is pretty similar across the board, because that can happen also if there's something out of alignment. So bottom line is, if those couple of tests work and it works out like we just saw, we pretty much can be pretty confident that this tuner is spot on aligned, and we really don't want to play with the alignment on it.
That line, that coon making some noise for organ that helps you digest food. But here's the thing, this place in you, which is filled with foreign critters, somehow this organ.
He turned back at the 41.
Hi, Elam feels the kick.
Elam trying to make a big play there, and thought if he could get back across the field it would work, but it did not work. So...
Okay, so let's plug the other microphone in. Okay, and so ends another restoration here, and I'm pretty happy with the way this thing turned out. Again, like I said at the beginning of this video, this is one of my favorite tuners out there for FM stereo. I just like the sound of it. It just has that warm tube sound to it. You know, there's other tuners that are so much more expensive and so much more complex and everything, and they definitely can perform at a higher level, but there's just something nostalgic about the sound of these McIntosh MR71s that I really enjoy. And I hope you enjoyed coming along with me for this repair. It was a lot of fun. So as always, I thank you all for watching. I thank you all for your donations and all your support, all the wonderful comments. And as always, I wish you all peace, joy, happiness, and good health in your lives. And until next time, stay well. And stay warm, because it's really snowing out there today for me. Take care. Thanks. Bye-bye.